We are going to be looking at radicals in this module, and we are going to start out by looking at simplifying square roots of variables being raised to a power. In order to simplify a variable being raised to a power when you are taking the square root, the power needs to be even. In order to do the square root, you take the power divided by which root you have. A square root is a 2, so you take the power divided by 2. On our first example, we are supposed to simplify the square root of x to the 48th. The first thing we want to check, is that power even? Yes, it is. So to simplify this, we are going to take the power of 48 and divide it by 2, so the answer would be x to the 24. On our second example, we're doing the square root of y to the 72 power. Is that power even? Yes. So our square root is 72 divided by 2, or y to the 36. Our third example has a number as well as a variable. Check that number. Is 49 a square? Yes, it is. Is our power even? Yes, it is. So the square root of 49 is 7, and take 10 divided by 2, you get v to the 5th. I have given you a list of powers starting with the squares, the cubes, and the fourths and the fifths. They are in order. On the squares, it's 2 squared, 3 squared, 4 squared, so on. You should know all of those numbers up through 15 squared, which is the 225. The cubes, the ones you are going to see the most, are 2 to the third through 7 to the third, and then 1000 is 10 to the third. On fourths, you're going to see 2, 3, 4, 5 to the fourth, and then 10 to the fourth is 10,000. You won't see a ton of fifth powers, but the first 3, 2 to the fifth is 32, 3 to the fifth is 343, and 4 to the fifth is 1024. A reminder to you, if you raise a negative number to an odd power, if you take something like -3 and raise it to the 7th, your answer will be a negative number. If you take a negative number raised to an even power, your answer will be positive. On example 2, we are being asked to simplify a variety of radicals. On our first one, we are to simplify the cube root of 27 and its negative out front. When there's a negative out front, that means that your answer will automatically have a negative on it. So we're going to have negative. And then, what's the cube root of 27? 3. On our second one, we are doing the cube root of -27. Can I do the cube root, an odd root, of a negative number? Yes, I can. The number that you multiply times itself 3 times to get -27 is -3. Our next example is the fourth root of 16. What number do you multiply times itself 4 times to get an answer of 16? That answer is 2. On D, we are being asked to do the fourth root of -16. When you are looking at an even root with a negative inside, there is nothing that you can multiply times itself 4 times and get a negative answer. Multiplying 4 times will always be a positive. What we write in this case is not real. On example 3, we are looking at different kinds of numbers that we are going to do radicals for. Our first example, we have the fourth root of the fraction 625 over 16. If you look at those numbers, each one is a fourth power. To do a root of a fraction, you do the fourth root of the top. The fourth root of 625 is 5, And you do the fourth root of the bottom. The fourth root of 16 is 2. B is very similar. We're doing a cube root this time of the fraction 343 over 27. What is the cube root of 343? 7. The cube root of 27 is 3. On C, we are doing the fifth root of 32x to the 10th. 32 is a fifth power. I already know that. For the variable, check, does the power on the variable divide by the root evenly? And it does. This means we can go straight to our answer. The fifth root of 32 is 2. For the variable, take 10 divided by 5, you get x squared. We're going to be simplifying radicals where what is given is not a perfect square, cube, or fourth. And so what we are going to do is look for the largest number we can find that is a perfect square, cube, or fourth that divides the number inside our radical evenly. If you also have a variable being raised to a power and the power does not divide by the root evenly, you look for the next number smaller than the given power that divides by the root evenly. Our first example that we are going to simplify is the square root of 48. 48 is not a number on our squares list. What I recommend you do is start from the larger values and work your way down, because I can look at this right away and see that 4 goes into 48. The thing is, 4 is not the biggest square that goes into 48. So let's start with the numbers that are just under 48 that are squares. 36 is a square. That does not divide 48. 25 is a square. It doesn't divide 48. 16 is a square. It does divide 48. So we are going to break the square root of 48 into the square root of 16 times 3. There is a square root rule that says you can break multiplication up into 2 separate square roots. Square root of 16 times the square root of 3. But I know what the square root of 16 is. It's 4. So the square root of 48 simplifies to be 4 square root of 3. Our second example is the square root of 128. I'm going to start bigger numbers. 100 doesn't divide 128. Next one down would be 81. That doesn't work. The next one down would be 64. 64 times 2 is 128. So I'm going to break this into the square root of 64 times 2. I'm going to skip that second step I did on the first example and go straight to my answer. I know that the square root of 64 is 8. The square root of 2 can't be simplified, so it stays inside the radical. For the square root of 28u to the 8th, 28 is not a perfect square. We're going to have to simplify that. My power of 8 does divide by my root of 2 evenly, so I don't have to do anything with the variable. Start thinking about the squares less than 28. 25 doesn't work, 16 doesn't work, 9 doesn't work, 4 does. We're going to break this into 4 times 7 for the numbers. We're going to leave the variable as u to the 8th. Now, the things that are perfect squares we're going to take out. The square root of 4 is 2. Take 8 divided by 2, you get u to the 4th. We can't do anything with 7, so it stays in the square root symbol. D is an example of what you do when your power on your variable does not divide evenly by the root. 27 does not divide evenly by 2. What we do is find the next number smaller than 27 that does divide by 2. Well, that's 26. So we would break y to the 27th into y to the 26th times y to the 1st. Now do the division for the one that you can. Take 26 divided by 2, then it comes outside y to the 13th. We can't do anything with the y to the 1st, so it stays inside as the square root of y. Next, we're going to do the cube root of 24w to the 11th. Neither of these items, the number or the variable, are perfect cubes. So we got to think about what is the cube that goes into 24. 2 cubed is 8. That's what we need to use. We're going to break that 24 into 8 times 3. When we look at our power on our W, it's 11, which does not divide by 3. Count down until you get somewhere that does. 10 doesn't divide by 3. 9 does divide by 3. So we're going to rewrite that W to the 11th as W to the 9th and W squared. We still have a total of 11, but we've broken it up because 9 will divide by the 3. It might help a little bit if you take the things that are perfect cubes and write them first. Put the 8 and the W to the 9th first. Then the extra stuff that is not going to be a perfect cube will still be at the end, and it will stay in the radical when you're done. So the cube root of 8 is 2. Take 9 divided by 3. Your power is going to be W cubed. Those things come outside the radical. The other items that you can't simplify stay inside the radical. For our last example, we're going to be working with a fourth root. Check your number, 81. 81 is a fourth power, so we don't have to do anything to that. In checking the power, I cannot divide 19 by 4 evenly. So I'm going to start counting down till I get a number that does divide by 4. 18 does not. 17 does not. 16 does. So we are going to rewrite our fourth root. We're going to leave the 81 alone. We're going to rewrite the x as 16, and then to get a total of 19, we're going to have x cubed. Now we're ready to do our root. The fourth root of 81 is 3. For the variable, take 16 divided by 4 and get x to the 4th. When you do the root of something, it comes outside the symbol. We can't simplify the x to the 3rd that's in our fourth root, so it will stay in our fourth root as x to the 3rd. The next thing we're going to look at with radicals is adding and subtracting. In order to be able to add or subtract any radicals, the radicands, which is the number inside the radical, has to match. You may have to simplify your radicals before you try to add or subtract so that you can create like terms. We're being asked to add the square root of 45 and 3 square root of 80. We can't add these as they are because the radicals do not match. They're not alike. So we're going to simplify each radical and see what we come up with. The square root of 45 simplifies to be the square root of 9 times 5. We're going to leave the 3 on the front. 80 is the product of 16 and 5. Our first radical will simplify to be 3 square root of 5. Our second radical becomes 3 times 4 square root of 5. Before we try to add, we're going to clean up that second radical. So the first one stays 3 square root of 5. The second one becomes 12 square root of 5. Now, we treat these exactly the same way we would if it was variables. Add the numbers in front. 3 square root of 5 plus 12 square root of 5 gives us 15 square root of 5. On B, we have the square root of 8 minus 4 square root of 50. We're going to break the square root of 8 into the square root of 4 times 2 minus, keep that 4 on front. How can we break down 50 with a square? 50 is 25 times 2. The first radical becomes 2 square root of 2 minus 4 times 5 square root of 2. Clean up that second radical, 2 square root of 2 minus 20 square root of 2. Now, add or subtract the numbers in front. 2 minus 20 gives me negative 18 square root of 2. Next, we're going to multiply radicals. When you're doing this, you have two choices. You can multiply first and then simplify the answer. Or you can simplify the radicals before you multiply. Multiplying first works really well if the numbers are small, but simplifying first works better when the numbers are large. Always check your answer to see if it simplifies. Our first example we're going to multiply is the square root of 10 times the square root of 5. Neither one of those would simplify as they are, so we're going to go ahead and multiply. When we multiply the square root of 10 times the square root of 5, we get the square root of 50. Now, check your answer. Does 50 simplify? Is there a square that goes into 50? Yes, there is. So, we've got to break that square root of 50 into 25 times 2, and then make it 5 square root of 2. Next, we have the square root of 6 times the square root of 3. Again, these don't simplify. They're both very small numbers. So we're going to go straight to multiplication. This is going to give us the square root of 18. Think about 18. Is there a square that goes into 18? Yeah, 9. So we're going to break this into the square root of 9 times 2, which becomes 3 square root of 2. Example C, the square root of 5 times the square root of 3z. Again, neither of those simplifies as they are, so we're just going to multiply. We're going to get the square root of 15z. Does 15 contain any squares as a factor? No. And z has a power of 1 on it. Can I take 1 divided by 2? No. So this is the simplified answer. Next, we're going to do the square root of 7w times the square root of 6w. Neither one of those simplifies. We're going to go straight to multiplying. This will give us the square root of 42w squared. 42 has no squares that go into it. But when I look at the power on that w, 2 does divide by 2. So we're going to actually do that division. Take 2 divided by 2, we get w to the first, and because we did the division, it comes outside, and then the square root of 42 stays as is. Next up, we have the square root of 80 times 3 square root of 20. These numbers are a little bigger, so let's check and see if they contain perfect squares. 80 does. 80 breaks into the square root of 16 times 5 times 3. 20 is the square root of 4 times 5. So the first radical becomes 4 square root of 5 times. The second one becomes 3 times 2 square root of 5. Now we have 4 square root of 5 times 6 square root of 5, cleaning up that second radical. Now you multiply the numbers out front, so we get 24, and then you multiply the radicals. The square root of 5 times the square root of 5 is the square root of 25. But that's a perfect square. So we're going to have 24 times 5, and then finally that equals 120. Next up, we have the square root of 48 times 3 square root of 98. Again, these are bigger numbers. If we multiplied 48 times 98, we'd get a huge number that we would have to try to find squares that go into. So it's much easier to simplify first. 48 breaks into 16 times 3 times 3. 98 breaks into 49 times 2. Your first radical now becomes 4 square root of 3 times 3 times the second radical is 7 square root of 2. Cleaning up that second one, we will now have times 21 square root of 2. Now that each of them is simplified, you multiply the numbers outside and get 84. Multiply the numbers inside the radical and you get the square root of 6. Check that square root, that number is 6. That does not simplify. So that is your answer. Next, we're going to take the square root of 6x times the square root of 2x squared. Those numbers are both small and can't be simplified, so we're going to leave them alone. In multiplying, the 6 times 2 gives me 12. X times x squared gives me x to the third. We have to check our answer. Is there a square that goes into 12? Yes, there is. So the square is 4 times the other part is 3. X cubed does not divide by 2, but x squared does. So I'm going to break x cubed into x squared times x. Now I'm going to do the square root of the 4x squared. Square root of 4 is 2. 2 divided by 2 gives me x to the first. Those come out. The other items that we can't do square roots of stay inside. We're going to take the square root of 10b squared times the square root of 5b squared. 10 and 5 don't simplify, so we're going to go straight to the multiplying and get the square root of 50b to the fourth. Looking at our number, 25 goes into that, so we're going to break 50 into 25 times 2. b to the fourth, 4 divides by 2 evenly, so we're going to leave it alone. Now, the square root of 25 is 5. Take 4 divided by 2 and get b squared. Those come out. The square root of 2 stays inside. The process doesn't change when you are using higher roots instead of just a square root. So for example, the fourth root of 6 times the fourth root of 8. We can't simplify those. We're going to go straight to multiplying. This will become the fourth root of 48. Now you have to check, is there a fourth power that goes into 48? Yeah, 16. So we're going to break this into the fourth root of 16 times 3. The fourth root of 16 is 2. We can't simplify the fourth root of 3, so it's going to stay as is. For our last example, we're going to do a fifth root problem. We're going to go straight into the multiplying. The fifth root of 20x cubed times the fifth root of 8x squared is going to give us the fifth root. 20 times 8 is 160. X cubed times x squared gives me x to the fifth. Now we have to check. Is there a fifth power that goes into 160? And there is. It's 32. So this will become the fifth root of 32 times 5. I left that space because our variable has a power of 5 which divides by 5, so it is a perfect fifth power. Now the fifth root of 32 is 2. Take 5 divided by 5 and get x to the first. Those come outside, and then the fifth root of 5 stays as is.